expressions and exponentially. So we're switching between that radical square root and the exponent with the power. That's our key thing. So understanding the difference between these two. So if we are looking at this one, it says use your calculator to complete this table. Now, you know the square root of 9, right? So we don't really need our calculator. We should have 3. And so if you have a calculator, take one out. If you don't, I have a couple of ones up in front that you need. We know the square root of 36 also is 6. So it says on your calculator to help with fraction powers, most calculators have that caret key. So there's graphing calculators too, right? It says use that to enter the exponent. And you have to, we talked about this earlier, when you're going to 27 to the 1/3, you must put 27 to the caret and then 1 divided by 3. Some of your calculators don't have that caret, they have y to the x. You still have to put 1 divided by 3. So, square root of 15. Someone have that approximate for us? What'd you have, Kylie? Approximately 4, and it came out to be what? As a decimal. We'll put it on your calculator, right? You have a calculator. Square root 15. In your calculator, what do we get? Yes, Whitney. 7 point. Really? Not divide by 2. And if you're putting it in your calculator, 3 point what? 3.8. Okay, gotta have parentheses. Square root of 24. On your calculator, what do we get? Almost. This 4.8, almost 5, right? When you put in 24 to the 1/2 power, did you get the same? Same with 15 to the half, 36 to the half, 9 to the half. So if we are looking at this, what do we notice about our pattern? That the square root, anytime we have a square root, right, where our index is not written in here, but it's always assumed to be a 2, that is the same as taking whatever the base is here, right, and taking it to the 1/2 power. Okay? So this square would be right as a 1/2. So it says, does this work for cube roots and going with 1/3 if we are looking at it? So the cube root of 27, right, we know is 3. If you want to check the cube root of 64, we know the cube root of 64 is 4. Some of you did great on that memorized quiz. Some of you might want to do a retake on that. If we are looking at taking 27 on your calculator, and you are going either if you have to use the y to the x, or if you have to use that caret key, and then 1 divided by 3. Did we get 3? When we take 64 raised to the 1/3 power, do we get our 4 again? So the relationship stays the same as we are looking at those. So this is going to be key as we are doing this assignment today. So that next part down says in your notes for the vocabulary. Abby, you want to start reading first?
In a radical expression, the number under the radical sign is a radicand. The number in the front of the radical sign is the index. The index tells us the degree of the root. If there is no index, the degree is 2, a square root. If there is a 3, it is a cube root. If there is a 4, it's a fourth root, and so on.
So if we are looking at this, as we are looking at our note, so the square root of 25, 5, 25 to the 1/2 is also 5. Therefore, if we are looking at this, our index goes always in the denominator, and the exponent, that whatever power it's raised to, is what's in our numerator. Okay? So the index and the number of the exponent radicand are used to form a fractional exponent as we are looking at this. So as we look at this, it says the key concept is if we are taking that nth root of that. So the nth root of a is a real number where m and n are positive integers. Then 1a to the fraction, exponent, 1 over n, is the same as taking the root, radical, with n as our index. If you have a fraction with a numerator and denominator, the numerator goes with this one. It could be written this way, and it could be written this way. So both ways. If we are looking at this, as we are looking at our note, okay? Which is kind of nice when we do our assignment as we are looking at this. So if we are starting at, and what they're going to ask you to do on the test, I will ask you to convert it to radical form. Just means you're not simplifying anything at this point, you're just writing it in radical form. So you have a fraction. So we are going to have our index. What should be out for our index? What number? 6 or 5? Always the denominator 6. So I'm going to add to the 6th power, and I'm going to add k to the 5th. Try the next one with m. In the index should be 3. So it's just going to have the third root of m, or if you want to put the 1 in there, I won't ever mark that wrong, right? So make sure you're writing these down. Okay? So we go to this one, and here's where students get confused. What's raised to the power? Only the x, right? Only the x. So when you start looking at this, we are going to have the 5 out in front, and then it's going to be the 4th root of x to the 3rd. The 5 is not raised to, if it would have been in a parenthesis, then I would have had the 5x, that whole thing in a parenthesis to the 3rd, but it was not. So you got to be careful for that. So try that last one, please. So as you're looking at that, we should have the 12. Cube root of a to the 2nd. Okay, making sense how we're switching those? So on the test, you're going to be asked to do that same thing. They're going to ask you to convert from fractional form, where you have an exponent, to radical form. Then you're going to go the other way. So if we're looking at grouping symbols also, if we're kind of thinking about this, 3x to the 2nd, if we are looking at that, that really means 3 times x times x. Whereas when you have that whole parenthesis raised to the 2nd power, that means 3x times 3x. Then you can use the commutative property and multiply your two 3's together to get 9, and x times x. So our final answer would be 9x squared for that one, whereas this one is just 3x squared. So it says the problems work the same way when we are looking here. So we have the whole thing in parentheses. So we are going to start with taking 81 to the half, and we are going to take m to the half. So if we are writing this in radical form, can we find 81 to the half? Square root of 81 is 9. Square root of m, so in our simplifying, like you did yesterday on your worksheet, if the variable is to the first power, you can't pull it out of the square root, so it stays underneath there. Okay? So we're going to start with this next one. If we are looking at 8y to the 2/3. My hint when you are looking at this is if you start with 8 to that 2/3 power. So when we are looking at that, we're going to write it as 8 to the 2/3. And we are going to have our y to the 2/3. Now, 8 to the 2/3 means we are taking the cube root of 8, which is what? Is 2, and then you are squaring it, right? So I get 2 squared. Now you can put this whole thing in your calculator also, and you should get 2, or 4. 2 squared is 4, right? Because this was 2 squared, so that gives us the 4. And then we have the cube root of y to the 2nd. So again, we're going to go to this one. We are going to take 32, and we are going to the 4/5. What does that mean? That really means the 5th root of 32 to the 4th. 5th root of 32 is 2. 2 to the 4th gives us 16. We're going to have a to the 4/5. So our final answer is 16, because you had to take 32 to the 4/5. and then it is going to be what root? What's our index? Index should be 5, right? And y, a, not y. A is going to be to the, what power, if I'm looking at it? To the 4th. Okay? If you look at these two, the difference here is our answer is going to be 8 to the cube root of y squared. So when you're looking at these two, when you have that whole thing to a parenthesis, 8 to the 2/3 with a parenthesis, our answer is 4. Whereas here when it's not, so very similar. Some of you will get those mixed up on the tests or on quizzes. So making sure you're understanding that. Again here, 32, the 5th root, a to the 4th. We don't have much bucket for notes on this one. On the top of the next page. If you are looking at the top of the next page. As you are looking at this, so as you look at this page, we are now switching back to from radical to exponent. So we are going to rewrite that. What should our denominator be? No problem. Do you have your pass?
No, it's down at about
No problem. So if we are looking at this one, what's in our denominator? 3 or 5? Should be the 5, right? Denominator is going to be our index. So b to the 3/5. How about this one? Denominator should be 2. K to the 1/2. Is 12 going to be raised to a power?
No.
No. The x is going to be to the 4/3, right? Make sure you have all of these down. Some of you missed a few. Make sure you get them all filled in. So this next one, though, as we are looking at this one, we are going to take 27 if we are starting off. We're taking 27 to the 1/3. What is 27 to the 1/3? 3, right? Then we have D, and we are taking that to the 5/3. So that when we look at our answer, our final answer should be 3 and D to the 5/3. Are you in the band thing too? Yeah. So check with me and I'll get your test back to you. So in our beginning notes, one of the first things it said is that there is no root. The index is always 2. So it's not written in as a 2, but that's where the 2 comes from. Just knowing that anytime it's a square root, that's a 2. So those of you that are gone, I'll get your test back to you.
G3.
When we're converting to exponent form, these can be the most difficult type of problems to do as you are writing them. So it says we are looking at the square root of 4y to the 5th. You are first going to take 4 to the 5th, y to the 5th. That's what that means when it's written in a parenthesis. So going back to our last unit with exponents. So 4 to the 5/2 and y to the 5/2. That means you're taking the square root of 4, which is 2, and then taking it to the 5th root. That's where they get the 32. Okay? You're keeping the fraction as 5/2 when we are looking at this. So if we are starting off with the 256, we might think of writing our 256 to the what power? 1/4. Okay? You're going to use your calculator. So you're going to put in your calculator 256 to the 1/4. Could you take the 4th root? Same thing, right? What'd you get for a number? 256 to the 4th power is 4. You are then going to have your A is going to be to the 8/4, but we are going to simplify 8/4 to be simply 2. So the nice thing about the variables, and the reason I want to talk about this is notice you are just taking these variables when you have a variable to an even power and you have an even power here, you're just dividing those to get the simplified form. So when you think about that worksheet of 209 that you were doing, same type of stuff, right? So if you take a look at this 209, okay? As you are looking at this with your variables, I think I saw questions on letter T. There's a couple of T's. Which one do we think? This one, or someone help me out? Which one are we talking